So in this and the next few videos, I will be differentiating some famous or some very useful matrix expressions that show up a lot in many different applications. So let's start. In this video, I want to differentiate y, which is equal to ax with respect to x. So I want to differentiate ax with respect to x. Actually, this will turn out to be equal to a, and this might seem natural, but this has to be proven. So let's start. Suppose we have a matrix A, assuming it is a 3 by 3 matrix, A11, A12, A13, A21, A22, A23, then A31, A32, and A33. If you multiply this matrix by the vector x, x1, x2, x3, you will get the vector y. Now, the first component right here in this vector is really equal to a11 x1 plus a12 x2 plus a13 x3, which is in general a summation of a1 k x k, right? Summation over k. And this summation is valid whatever the dimension of the matrix was. Now for the second element, I have another summation starting a2k multiplied by xk. Here I have another third summation a3k xk, and we can continue if we have higher dimensions as we want. So this is really equal to the vector y. So this is equal to y1, y2, y3, and we can continue. Now we want dy by dx. Remember, y is a vector, x is also a vector, and so this will be a matrix. Here we will have dy1 by dx1, dy1 by dx2, and dy1 by dx3. Here we have dy2 by dx1, dy2 by dx2, and dy2 by dx3, and finally we have dy3 by dx1, dy3 by dx2, and dy3 by dx3. Now let's try to get those values for our specific example. Now y1 is equal to this, which is equal to this element right here. Now what is the differentiation of this with respect to x1? Clearly the answer is a11, because a11 is multiplied by x1 and all the remaining elements are independent, so this is equal to a11. Similarly, the differentiation of y1 with respect to x2 will be a12, and here we will have a13. Now the differentiation of y2 with respect to x1, so y2 is this, which is equal to this, so I will have a21. So a21 here, a22 here, and a23 here, and finally a31, a32, and a33, and you can continue for larger dimensions, and this right here is really the matrix A, and so dAx by dx is really equal to the matrix A. I want you to note that if we had chosen the Jacobian right here to be the transpose of the Jacobian, or defined this derivative to be the transpose of this matrix, then the derivative of ax with respect to x would have turned out to be A transpose instead of